Assalamu alaikum. Welcome to the next in our series of Pakistan at 100 podcast. I'm Hibah, Sheikh, and today we're joined by Sameem Siddique. Thank you for joining us. So far, we've looked at issues about which affect Pakistan today or will do in the near future. But today, we're going to look at how the research and technological landscape has taken a shift and how, with the advent of machine learning and systems such as GIS, we're moving on and how we can impact policy making before issues arise and try to solve them. Sameem Siddique is a PhD student at the Department of Economics at UC San Diego. His research interests mainly lie in economic development, labor economics, education, and conflict. He studies bottlenecks that impede provision of public goods and services and how policies can be designed to alleviate such constraints. For today's podcast, we'll be discussing new techniques used in economic research to um, improve our academic area. So, Sameem, the field of economic and policy research is rapidly expanding due to availability of all of these techniques, which allow us to either gather more data or analyze data in depth. Can you generally expand on these techniques?
Yeah, I think because of the advent of technology and these huge leaps that computer scientists have made, and because we have so much computing power now, there are so many advances and there are so many new techniques available. But I think like some of the more intriguing and trendy techniques that sort of one hears about much more often now are machine learning, GIS, and remote sensing. So these are like some of the things that like I think uh, like we'll be talking about today.
Yeah. So you mentioned machine learning, which is basically the construction of algorithms in which you can learn from and make predictions on data. In very layman terms, it basically allows us to learn from existing data. But what economic research is basically the ability to develop causal relationships between two variables. Insofar as for example, an economist might sift through real estate data to figure out how factors such as size, location, etc., affect the value of a house. But what a machine learning system would do is simply predict a good, accurate value of the house without linking any of the factors. So, in light of the fact that machine learning doesn't directly offer us insight into relationships, how can we take advantage of this method and how can we take it forward into our research?
So it's true that machine learning doesn't give us like causal estimates between x and y, but that doesn't mean that it's not useful. So machine learning is very good at what it does, and what it does is prediction. But I think the important thing to note is that not all policy problems or not all questions of interest require causal inference. So there are a bunch of examples and use cases where it's where the prediction value is more important than the causal estimate. And I think like the example that you give, the real estate market, I think that's one of those because it might not be while, and it depends on who's interested in what sort of question. For somebody who's maybe constructing a house and wants to do this as an investment and wants to know what's the additional value of creating of like building in one additional bathroom in my house is going to be for the price of my house in the long run. Something like that, something like a causal effect would be
Useful.
useful,
Yeah.
right? But then for somebody who's thinking about um, uh, investing in a house and wants to know what the value is going to be somewhere down the line. I think some predictive something that predicts where they're thinking of investing is going to be valuable or not is useful,
Is more useful. Yeah.
right?
Okay.
So I think broadly, while the definition of machine learning that you said is right, there's there's I mean, I was recently reading an article where somebody was saying that you could have like an entire day's worth of a conversation to sort of talk about what machine learning actually is and how you define it, because different people use it very differently. I think artificial intelligence is also one form of machine learning, although that becomes like really techy, and I just want to sort of stay away from that. But it basically helps, and I think, and it's not a new technique; it's been around for a while. But the reason why it's becoming pretty popular because of how I mean how much access we have to computing power. So we have like really like
Very powerful computers.
exactly,
Yes.
and we have a lot of data that's available.
Right.
So machine learning can help with two broad things. One is, so if we have very large data sets, so we have fewer observations, but we have a lot of characteristics or a lot of variables about those observations, then machine learning can help us determine, like, it's basically that process is called shrinkage, where it helps us determine what are the important variables among others. So facial recognition, for example, is an example of such a case where you have like a lot of your data. If you take a picture of my face, you have a lot of information that you can get from that.
Okay.
But then you can basically shrink that to sort of identify key features or key aspects that define who I am versus who you are.
All
Right? That's an
Right.
example of machine learning. Other examples which are more towards prediction are if you have like large amounts of data and you can train an algorithm to say you can train an algorithm and use that algorithm to make a prediction somewhere out of the sample. So this is a bit unclear, but so an example of this use case is, for example, Netflix. The reason why Netflix is really popular is because of its ability to predict what you like and what you dislike and do that really, really well.
Yeah.
Right?
And offer the right recommendations.
Exactly, and offer the right recommendation. And the way it does it is when you start watching something, you say whether you like it or dislike it. Machine learn the algorithm that runs behind in the whole Netflix black box thing is that it updates your preference, and then the next recommendation it gives you sort of is along the lines of what you like and what you dislike.
It's more suited to your areas of interest, basically.
Exactly,
Right.
exactly. Now there are so these are very generic examples, but and one might ask, how is this related to economic or policy research? Um, it's basically thinking about problems in terms of prediction, policy problems that have to do with prediction. So one example is so this was recommended by a group of economists for like as a use case for machine learning is that so hip replacement surgery is a costly process and it's both in terms of time because it takes a lot of time for one to recover in terms of the actual monetary cost of doing it and just like the pain that goes into it. Right? So they sort of suggested using existing data to predict, to sort of develop an algorithm that predicts whether one survives a year after having hip replacement surgery or not. Like to predict whether one would survive a year after hip replacement surgery or not, and use that as a decision to determine whether somebody should get hip replacement surgery or not.
But doesn't something like this depend on a lot of factors based on an individual? How likely that is? I mean,
Yeah, it does. But it's this again. This is only suited in places where you have that much data.
and a similar sample, so to speak.
Not necessarily.
No?
Not necessarily. Because if you have a lot of data,
Yeah.
then you have the different sorts of people who are ever going to come to a hospital for hip replacement surgery. Of course, I mean, I'm not suggesting that this just be like done universally. Of course, there needs to be like measures in place that determine whether how accurate the prediction is, how much of a weightage it should get in a decision.
In your decision making.
Exactly,
Yes.
exactly.
Of course.
But it could still be useful. Another example is when, so for example, when I'm saying the word example a lot, but anyway, is when somebody gets accused of a crime and they're waiting for their trial. Judges can decide whether to put that person in jail or whether to post bail.
Okay.
Right? But the trade-off basically is that if you put this person in jail, it's going to be costly. Right?
Using up government's resources.
Exactly. But if you post bail, there's a chance that they might flee.
Yeah.
Right? So there's a trade-off. You could so machine learning can help judges make predictions about how likely one person is to flee or not flee if they're posted bail, and use that as part of their decision to post bail or not.
All right. And
so basically, just to help judges make decisions about whether to post bail or not.
But I think one question that further arises from this is, can't data be manipulated in a way to bring out results that by people who, let's say, in a specific case, don't want somebody to get paid, whether they're likely to flee or not.
I mean,
And this
if that I feel like that's true.
for all technology, so to
That's
speak.
all true. But then that's true for everything.
Exactly.
And I think like one requirement for one requirement to be able to do all of this in the first place is to have like strong institutions and like procedures in place that like
That check the system. Okay. Right. And then moving on, you also mentioned geographical information systems and how basically GIS is supposed to capture, store, manipulate, analyze existing geographical data
yeah,
and form spatial databases. It's pretty common. It's basically it exists everywhere in academic geography, planning, natural resource, everywhere. How is it that this it's been existed for a very long time, but in recent history or recent past, sorry, it's gained more traction. So why is this so? Why has it become so popular all of a sudden?
if I have to give one reason,
Yeah.
I think it's the cell phone.
Okay.
Because we all now carry devices in our pockets
Mm-hmm.
that track where we are.
Mm.
So that provides like a big dimension to do research, not just research, but also for policy problems for monitoring and stuff.
Right.
So the Punjab Information Technology Board
Yeah.
uses this a lot. So a lot of so PITB has equipped a lot of service delivery people
Mm-hmm.
in different departments
Mm.
with cell phones, which they sort of use not only to collect data through like forms that they through applications that they have in those built into those phones,
Mm.
but also they can also sort of track people's locations about whether they're going to point A or not,
Mm-hmm.
to the point where they're supposed to or not. And I think
Right.
because you have that information,
Mm.
you can use that, like one can be creative and use it in many different places. I think like so specifically for economic research, I think like people are sort of realizing that. So let me just give like a very academic example.
Mm-hmm.
When designing an experiment and an RCT where you have to randomly allocate some of the subjects to a treatment group and some
Mm.
subjects to a control group, you want to do that so that both groups are very similar, so that one gets a treatment and the other doesn't. By comparing the two, you can come to a causal estimate of
Yeah.
what the effect of the treatment was on the outcome variable.
Mm-hmm.
Now, one of the ways people try and ensure that the treatment group and control group are similar at the point when treatment assignment is made is by stratifying your data. So,
Okay.
for example, what that means is let's suppose the sample consists of both men and women,
Right.
right?
Okay.
One way to sort of allocate that sample to a treatment and control group would be to mix the whole population
Yes.
together
Yeah.
and then randomly allocate half to treatment and half to control.
Right.
But then the worry there, and that obviously depends on other factors like sample size and whatnot.
Mm-hmm.
But the worry there is that it could be possible that your treatment group consists of more women
Versus men.
compared to
Yeah.
the
Yeah.
versus men
Yeah.
compared to the control group.
Mm-hmm.
So now you don't know when you once the treatment is administered and you control the treatment and control group,
Mm.
you don't know whether the difference is arising because of the treatment
Or the
with
gender.
or the gender,
Yeah.
right?
Okay.
So this is where stratification comes in, where you
Mm.
say that like I will do the treatment assignment separately in men
Right.
and then separately in women,
Okay. So
like
there is
at the
some
beginning.
control of the sample.
Exactly, exactly.
Right.
So in a lot of like recent work, which requires so this is like specifically at an individual level, this particular example. But then you can think of examples at the village level, where let's suppose some big intervention is supposed to happen at the village.
Right.
The control group would also be a village, but then you want to be able to compare similar villages.
All right.
So you wouldn't want to compare a village in like Kasur to a village in Bahawalpur because there's so many cultural differences.
Mm-hmm.
Now, prior to the availability of GIS and all of the spatial data, this wasn't really, people didn't really think about it that much.
Right.
Like you would do this, so there would be some stratification on administrative units, on tehsils or districts or whatnot.
Mm.
But I think even for like bigger tehsils, if you have like one village in one corner and the other in another corner, there are still some cultural differences or other differences that happen.
Definitely. Yeah.
I think with with time, people have started sort of realizing that location is a very big predictor of characteristics.
Yeah.
So
A lot of factors.
a lot of
Socioeconomic,
factors.
a lot of factors.
Exactly.
Yeah.
So people are now using geography more and more for stratification.
Right.
So like making sure that like two places are a pair that you want to compare to one another is close together in terms of geography and space versus another pair or other villages. So I think for analysis like that, GIS is becoming like more and more common. And that's just more like technical and academic side of things. I think like for even other things, for service delivery, if you want, so determining whether some places get service or not, distances to roads is a big thing.
Definitely.
Yeah, and
Definitely.
I think so. If without GIS, if one wants to do this manually, it would be like a very costly activity
Very
where
time intensive.
exactly where an enumerator would go and he would sort of measure the time when they leave the road and then the time that it takes for them to get there and measure the distance manually. You can all do that really quickly now on using GIS.
Yeah, using spatial maps.
Yeah.
Right. And remote sensing also comes as part of GIS.
So remote sensing is in its generalist form is encompasses is very generic actually. Like even using it's basically inferring something about something without directly getting in contact with that something.
All right.
So for example, just using a thermometer to determine what the temperature of the room is also in some sense remote sensing. Or just taking a picture and then looking at that picture to make inference about something. That's also remote sensing. Because
Or
it's,
building maps using satellites. That's
so in this
images.
context, in the GIS context, remote sensing is using satellite images, using satellite imagery to sort of using satellite imagery and then being able to extract data from that satellite imagery for use in analysis and use with storing that data in a geographic information system. So, which is why like GIS and remote sensing sort of go hand in hand.
Hand in hand, basically.
Yeah.
So our pool of data has basically expanded immensely,
Immensely.
given GIS.
Immensely. Yeah,
Okay.
definitely.
Okay. And in terms of applicability to, let's say, Pakistan, how do you suggest we apply these technologies to bring about more research and better service delivery, so to speak, in Pakistan?
So I think so. So I recently read an article in the Express Tribune where which sort of reported on PITBs. So PITB recently sort of has started doing crop mapping using satellite imagery. And I think that's a very important use case because it's very important for agriculture policy research. I think so. What they've done is you have an image of, let's suppose you have an image of, actually, let's think about like a very basic example. So let's suppose you have a satellite image of LUMS,
Okay.
right?
Right.
Now, using just that image, you can eyeball where the cricket ground is, you can eyeball where the football field is, and you can eyeball places where there isn't a garden. But that in itself is not, yeah, you're not storing that information in a geographic information system, right? Because that's still just an image.
Right.
So the way you would do that is you would apply different filters. You would apply different, either an infrared filter or you would apply like a spectral filter on it, which would highlight the cricket ground and the football field
Away from the rest of the
away from the rest of it. And then once you have that,
Right.
you can extract that and sort of say you can extract that to determine whether a pixel on the map is green or it's not green, like whether it has grass on it or it doesn't have grass on it.
Okay.
Right?
Okay.
So what sort of PITB has done is very similar, where so they have an image, they can see like if you scan the image, you can tell that this square patch over here is some form of a crop, and the part next to it, which is sort of brown, is not, because that's either
Not
that could be
green,
road or not green.
Yeah, of course.
So they applied sort of filters to determine what part, like what crop is going where. And I think there are a lot of many different variations depending on like the color of the crop and what
Of
crop it
course,
is.
yeah. Yellow, white, anything. Yeah.
Exactly, exactly. I mean, of course, there are nuances in there, and it's like I'm making it sound very simple. It's not that simple,
Yeah, of
but
course.
it's still like there are a lot of options available.
And it saves a lot of manual labor time, so to
Exactly,
speak, in
exactly,
terms of delivery.
exactly.
Yeah.
That's so. This is just an example of remote sensing by itself. It is being used right now
Mm.
for that case. What's more important, specifically for this example, for the agriculture, this like crop mapping example, what's more important is using that data to actively and creatively using that data for policy work.
Yeah.
So again, that in itself doesn't give any recommendations. That in itself
Doesn't cause a change.
doesn't cause a change.
Yeah.
It's how policymakers use that data to sort of come with policies. Other examples and examples where machine learning and remote sensing slash GIS could sort of come in handy is this paper. It's a paper that was published in Science in the Science Journal. I don't remember the name of the paper. I think it's called using remote sensing and machine learning to predict poverty.
Okay.
And what they sort of do is and this is based in Africa, I think, where they have pictures. The authors have a lot of satellite imagery, which and some places where they have, in some places where they have some survey measure,
All right.
and then they try and predict whether like an area is whether the rate of poverty in that area by by using satellite images. So basically, the different attributes that they get from satellite images, which is how dense that area is, how densely populated that area is, like how many houses they see in that place, the sort of the structure of the house. They can make some inference about the structure of the house. They create a model which they train that model based on the information that they're getting from satellite images
Okay.
and the survey data that they already exist
Right.
to predict different places, to predict the level of poverty in different places.
Okay.
Now that's
Right.
extremely powerful in a developing country where I mean, thankfully Pakistan is better in that sense because we do have good data publicly available. Well, we do have publicly available data, but in places where there's no way of getting data, this is an extremely powerful tool for programming. So if an NGO or if another aid agency wants to come in and deliver services at the community level, something like this can really help reduce costs because instead of first going down on the field and sending like manpower in to determine how poor the village is,
Where do you go?
where do you
How,
go, and
yeah, all of that.
it's just this process makes it a lot simpler.
I think service delivery becomes more targeted and effective then, in
Yeah,
this sense.
yeah.
Right.
Another example is, and this I think in this example it's not the machine learning doesn't come in, but satellite imagery sort of does. So there's an NGO called Give Directly,
Okay.
and the way they work is, they connect the recipient of a cash transfer directly to somebody who's directly to
The beneficiary.
so directly to the person who's sending money. So for example, if I want to help somebody, if I want to just donate money to Give Directly, I would just sort of send them a message or I would tell them, and then they would directly send that money to a beneficiary with nothing happening in between.
No third party, nothing.
No third party, no nothing. And the way they determine beneficiaries is by the material used for making the roof. So they don't go down into the, so there may be instances where they do that, and that depends on what program they're working for and what. But I think mainly what they do is they determine the material used for creating the roof of the house
Using satellite imagery.
using satellite imagery, and because usually in places where they operate, the material used is very predictive of the poverty level. I think it's tin.
Okay.
Tin roofs are like predictive of how poor.
How poor family is.
Yeah, yeah.
Right.
And they just sort of use. They don't go do costly surveys. They don't send enumerators down there. It's just directly, so just like there's this setup cost involved, which is just like setting up a cell phone and whatever. But then they're identifying beneficiaries this way. So there are interesting use cases which one can sort of be creative about in applying this.
Okay.
Yeah.
Right. And so basically, what does this then mean for policymakers in Pakistan specifically? Because if there's all of these techniques available, and if there's so much data available that we can work with, then why aren't we already progressing at 100%? In a way, I mean.
So I would slightly push back on the availability of data.
Okay. Just for Pakistan or overall?
Overallish, I guess. So yeah. I mean, I think just talking about specifically about Pakistan, I think like being able to use satellite imagery is different. Satellite imagery is that it's available at very low cost. Google has this separate search engine called Google Earth Engine,
Okay.
where you can access it by paying some money. And I think to academic institutions, maybe it might be free. I don't know, but it's still like relatively the benefit that you can get from it is
At a very cheap cost.
yeah. So satellite imagery is different.
Okay.
I think like even so places that you would imagine should use GIS are using GIS. I think like um, so for example, I think the urban unit is using GIS a lot to map different urban areas and different properties, and that helps a lot. That helps a lot for tax collection and for regulation and
Definitely.
stuff.
Yep.
So I think GIS and remote sensing is a little different. I think for machine learning stuff, it's we we have good. So we have surveys that happen regularly,
Right.
um, but it's difficult to access that information. It's difficult to access that data for research work. So usually in places, what happens is that so for data that's sensitive, that's data collected by so for example in the US, so all of this confidential data that's publicly collected, it's not publicly available, but it's collected by the government, is available for academics to work in
For the research.
for their research.
Right.
But you have to. I mean, there are processes in place where you have to register with them. There's a computer that sits like in my university. There's a computer that sits in the department
Okay.
in a room that's completely isolated. It's not connected to the internet. It's not connected anywhere. So if you want to do some work, you go into that room and you run your regressions and then you come out.
Right.
There are ways to make this happen.
Okay.
But it's just we haven't really thought about those. Like in Pakistan, we haven't really thought about those. And then
I don't think there's any such room in Pakistan where.
I don't know.
Yeah.
There may be, but at least not to my knowledge. And then I think the environment and the mindset for it. So the environment in organizations to be mature about their data, to think really carefully about how data needs to be stored.
That's very important.
That's very important.
Yeah.
Like even for example, schools, right? It's very important that different attributes for the same student, like because we've handled data so much, we know that we can make the most out of it once if the data for the same student appears in the same row, or there are identifiers in the different data sets. So if I need to put them together, I can do that.
Right.
But people don't think about it that way. People in organizations don't think about it that way because they're more focused on delivery and they're more focused on doing rather than being able to think about it later down the line. At least that's the impression that I'm sort of getting. So I think like for policymakers, what this sort of means is that we need to be for policymakers. What that means is that there needs to be emphasis on educating organizations and key people in these organizations on how to manage data, so that it's useful. If one can't think of a reason why it's useful right now, it may be useful sometime
Later on. Yes. Okay.
So we should be prepared for that.
Yeah. And one way to educate these people and to make sure that there are people thinking about it is to focus on aspiring researchers who are currently trying to enter the stream.
Yeah.
And so, what would you tell them?
Um, so two aspiring researchers and students who are thinking of pursuing PhDs or who are thinking of coming into policy work, I would highly recommend. So, in my experience, I think this whole field is becoming increasingly competitive.
Alright.
Students who go to pursue their PhD programs are very well versed in, especially those who have like 2 or 3 years of experience doing RA work for professors or have worked on research projects, have a lot of experience with these different softwares, have experience with coding, and so I think for students here who are interested in pursuing higher education or um, something along these lines, I would sort of highly recommend that they should be forward looking in what they want to do and plan accordingly from now on.
Okay.
So, for example, for a sophomore or junior student at LUMS, I would recommend that they should take courses other than taking courses in economics. Of course, not every student, economics.
Well, yeah.
They should, other than taking courses in economics, they should be taking courses in math and they should be taking courses in computer science. The more well versed they are with these languages and tools, the better it's going to be. It's easier. It's going to be easier for them to adopt those things later
In their
down
careers
in their
later on.
careers
Yeah.
when they have to learn.
Right.
So, like recently, I was having a conversation with somebody, and I was like, even if it takes time, it's investment for you that is going to give you a lot of benefit somewhere down the line. Where if you just go meet with somebody, talk to them, see where you can see where you can use GIS in, and just use their data, talk to them, and then just like play around with it. Play around with it, come up with like make different maps, try and see what other things you can infer from that data and relating that in like a putting that in a GIS sort of context, just so you get familiar with the software, and because you see like the potential and like see what more is out there. So
Okay.
yeah.
And I think conclusively keeping in mind our Pakistan at 100 theme, where do you see research in Pakistan and research for Pakistan headed in the direction by 2047, let's say?
So so I recently over the summer I had the pleasure of doing like some field work in somewhere else as well, other than Pakistan, in a middle/developing country. Um, and so prior to starting my PhD, I did like 3 years of field work in Pakistan as well.
Okay.
And so when I went there, I don't want to say the name of it. When I went there,
Right.
it's just to me it was like a bit of a shocker because I mean I've so used to Pakistan, and it sort of made me realize how much how developed we are
Alright.
in the networks and tools, not tools, in the networks and in the services available to researchers. Like we have a very well connected network here, um, that I think that I've now come to realize is really conducive to doing good work.
Right.
And I think sort of if policymakers become more um, realize this, like the potential that researchers can bring on board and how much we can gain from this, I think we can do a lot. Like I think with organizations like the Center for Economic Research in Pakistan, Ideas,
Ideas,
Consortium for Development Research Policy, I think, and even here at LUMS, it's the the academic network I think is very strong.
Right.
I think services available in terms of like doing survey and enumeration, um, availability of like people who know like some. I mean, I guess like the for different interventions or different research that you want to do, there are people who can help you out in doing those.
Of course, yeah.
And I think that's something. I think for that reason, I think that like by 2047, I think things to me look pretty good for in terms of research. Things are looking good for Pakistan.
There is hope for us.
Yeah. I mean, in a joking sort of way, I think one of the reasons why the research network here is really strong is because we have a lot of problems and people are interested in those problems.
Right, of course.
But I think we're doing well in terms of like the research work. I think, um, but we should be able to do a lot more if we find cooperative partners in the public and policy space.
And I genuinely think there's a lot of people who are trying to do the right research in the right ways. And I feel like the techniques that we discussed today will be of much help,
Yeah.
especially if aspiring students start to learn these techniques and figure ways out.
Yeah.
All right. Thank you so much, Sameem, for your time
No
today.
problem.